Okay, so this next example is another Coulomb's law problem, but it's with three charges in a straight line. So basically you have a 70 microcoulomb charge that's positive, a 48 microcoulomb charge that's positive, and a negative 80 microcoulomb charge. And it asks, well, it says that these are 0.35 meters apart, and so are these. And they want to find the net force on each charge due to the other two. We're not going to go through all three, but what we'll do is we'll find the net charge on the left charge, or net force on the left charge, excuse me. This is page 497, number 11. Okay, so you have more than two charges here, so there's going to be more than one force. So the best thing to do when that's the case is always draw a free body diagram of what forces are acting on the charge in question. This charge is the 70 microcoulomb charge. It's going to get pushed to the left by the second charge. So I'm going to call that force 1, 2, force of object 1 and object 2 on each other. And then the 80 microcoulomb charge is going to pull the positive 70 towards it in this direction. So we'll call that F13, the force of 3 on 1. Okay, we're going to find each force. So we'll use Coulomb's law twice. So F12 is going to be K, which is 9 times 10 to the 9th, times Q1, which is 70 times 10 to the negative 6, since we convert to coulombs, and times 48 times 10 to the negative 6, since we convert to coulombs. We divide that by the distance between them squared, which is 0.35 meters, and square that. We'll punch this all into the calculator. 9 times 10 to the 9th times 70 times 10 to the negative 6th times 48 times 10 to the negative 6. We get 30.24 divided by 0.35 squared. We're getting 246.9 newtons. And then F of 1 on 3, those two, it's going to be K again, 9 times 10 to the 9th, times Q1 again, 70 times 10 to the negative 6th, times Q3 is 80 times 10 to the negative 6. Notice I didn't put the negative sign in. I always use the absolute value here. The direction will take care of everything else. The distance between 70 and negative 80 is 0.7 meters. Have to square that. Okay, so here I have 9 times 10 to the 9th times 70e negative 6 times 80 times 10 to the negative 6th. That's 50.4 divided by 0.7 squared. I get 102.9 newtons. So the net force, if you look at the diagram, is going to be 246 to the left and 102.9 to the right. So 246.9 minus 102.9 equals 144 newtons to the left. Someone might say, well, it's negative 144 newtons. It depends on how you define your positive and negative directions. But this is an example of a problem where you have multiple forces. You have to draw a free body diagram with vectors. Use Coulomb's law, which, if you remember, Fe equals K Q1 Q2 over R squared. That'll give you the magnitude of the force. Okay, we're going to use that for each force, and then use the free body diagram to add the forces as vectors. In this case, they were in opposite directions, and we came up with the net force.